organic chemistry question from winter 19 paper. Normally you will find the last question from organic chemistry. In question 5, part A, the part of a structure of a synthetic polymer is shown. Synthetic polymer means man-made polymer because the polymers can be synthetic, it can be natural. Synthetic polymers such as nylon, tyrrolene, polyester. So, what type of synthetic polymer is A? So, how to identify that? Because there are two types of polymers. One is addition polymer, another one is condensation. How to identify it is an addition polymer or a condensation polymer? If it is an addition polymer, then the molecules are linked by a carbon chain, like carbon atoms linked with each other. If it is a synthetic condensation polymer, then there will be there might be a peptide linkage, there might be amide or a peptide linkage or ester linkage will be there, but not carbon-carbon link. So how to identify?
So, Mr. It's additional.
So it is addition. Why? Because you can clearly see all the molecules are linked by a carbon chain. So whenever all molecules are linked by a carbon chain, that type of polymer is addition polymer. Then deduce the empirical formula. How to deduce the empirical formula? Empirical formula for these all addition polymers, it is always CH2. For addition polymers which are formed, because addition polymers are formed from alkene. Alkene have the empirical formula CH2, so their polymers also have the empirical formula CH2. The simplest ratio between the carbon and hydrogen, it is always CH2. Or you can also work out the empirical formula by counting if you want to. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 carbon. We count hydrogen 3, 6, 9, 12, 15, 18 and down also 18 plus 18, 36. So what is the simplest ratio between 18 and 36? When I simplify, it will be, because we divide by the common factor, so we divide both of them by 18. So 1 carbon and 2 hydrogen, or CH2 I can say, the empirical formula. Because empirical formula shows, yes.
We will count the carbon, it's 18. From where? The middle or upward?
Total number. 1.
Sorry, Mr. I thought 3 was also carbon.
No, this is hydrogen.
Okay.
You count the total number of carbon and total number of hydrogen to work out the empirical formula. And after getting the total number, find the simplest ratio, you will get the empirical formula. The next part, draw the structure of a monomer. How to draw the structure of a monomer? So the simple technique you will use, you will hide, just take the first 2 carbon atoms and hide the remaining structure. Just take the first 2 carbon atoms in the chain and hide the remaining structure and draw as it is. So we'll draw as it is what was there, like what is appeared now. So 2 carbon atoms are there. This will be CH3, this will be CH3, this will be CH3, this is also CH3. And between the 2 carbon atoms, there is a double bond. So there will be C double bonded with C. Because in a monomer, whenever you have a monomer should have a double bond. A polymer will have like double bond, you break and you link the small molecules together. So from polymer, we can deduce the structure of a monomer as well. Then the formula of C4H10, which is a butane, has two different structural isomers. What is meant by the term structural isomers? What is the meaning? Structural isomers, compounds have the same molecular formula, but different structures. We call them as structural isomers. Then draw two structural isomer of C4H10. C4H10, what is this? Alkane or alkene? C4H10. Is it alkane or alkene? ANE or ENE? So C4H10, that's right, it is an alkane. So whenever you have alkane, because the number of the hydrogen are twice plus 2, that's why it is an alkane. So whenever you draw the isomer of alkane, as we discussed, whenever we are drawing isomers of alkene, we try to draw in two ways. First one, we draw a straight chain. And the second one, we will make a branch. Whenever we are drawing the isomers of alkane, the first one will be a straight chain and the second one is a branch. But when we are drawing the isomer of alkene, then there are three possibilities. We can change the position of a double bond. We can make a cyclic alkane, or we can make a branched. But as I advise, try to make either change the position of a double bond and then cyclic. Because sometimes you have to name the structures as well, so it will be difficult to name the branched alkene. So here we have to draw structures and we have to show for all the bonds. So first, 4 carbon atoms in a straight chain. Carbon can maximum form 4 bonds, so this will have 3 hydrogen. And you are not supposed to write like CH3 here. Why if you write CH3, it will be considered as wrong. Why? Because they already mentioned show all the atoms and all the bonds. This statement is there. So you have to show all the atoms and all the bonds. That's why this will have 3 hydrogens. This will have 2 hydrogen. This will have 3 hydrogen. And this will also have, this will have 2 hydrogen and the last one will have 3. And to draw a cyclic, we draw 3 carbon in a straight line and 1 as a branch. So this will have 3. This will have 3. This will have 3 and this will have 1. So these are the 2 structural isomers. To know whether your structure is correct, you can simply count the number of atoms. Like here, 1, 2, 3, 4 carbon atoms are there. And when you count the hydrogen, it will be 10. Here also, 4 carbon and 10 hydrogen. So means your structures are correct. All structural isomers C4H10 are flammable. Write a chemical equation for incomplete combustion. Complete combustion gives off carbon dioxide when the molecule burns completely. But incomplete combustion, you can produce carbon monoxide or you can also produce carbon. So it's up to you. Any one way you can complete. So example, if I complete with C4H8 reacted with oxygen, gives carbon monoxide in complete combustion and water, H2O. For a combustion equation, whenever you want to balance a combustion equation, we start with carbon followed by hydrogen and at the last oxygen. That's the order of balancing a combustion equation. So we start with carbon. We have 4 carbon on the left hand side. So there should be 4 carbon on the right hand side. So carbon is balanced. We have 8 hydrogen on the left hand side and 2 only. So we put 4 hydrogens balanced. What about oxygen? Here 4 and 4. So 8 oxygen. So we need 8. So we put 4 here. So oxygen is also balanced. So this equation is balanced. but in the question, it is C4H10. Sorry, I took C4H8. I took butene, but it is butane. So the original molecule, I took C4H8, but it is C4H10. So 4 carbon, we put 4. So carbon is balanced, hydrogen 10. So we put 5, hydrogen is balanced. And now oxygen, we have 4 here and we have 5 here. 4 plus 5, 9. So how to make 9? It will be 4.5. Or you can write in fraction here, 9 by 2. So 9 by 2 oxygen are there. So it will make, or if you write here 4.5, whenever you need a decimal to balance the equation, what you will do, you will multiply all of them by 2. So when we multiply all of them by 2, the final equation will be, this will be 2. 4.5 multiplied by 2, that is equals to 9. 4 multiplied by 2, that will become 8. And 5 multiplied by 2, that will become 10. So this is the balance equation for incomplete combustion of butane. Question is about ethanol, manufacture of ethanol. Ethanol is ethanol that is suitable for use as a fuel can be manufactured from sugar such as glucose by 2 steps. Describe how this can be done. In your answer, include an equation in which ethanol is formed, essential condition for the reaction in which ethanol, this is basically a fermentation, and the name of a process used to obtain ethanol from this pure, that is pure enough to use as a fuel. So this method is known as fermentation. And how, what happened in a fermentation when we have a sugar solution, C6H12O6, in the presence of yeast, which is having which enzymes act as a biological catalyst, it produces carbon dioxide and it produces 2 molecules of ethanol, which is C2H5OH. What are the reaction conditions? Anaerobic respiration, so means in the absence of oxygen. Anaerobic here means no oxygen should be there, around 25 to 30 degrees centigrade. In the presence of yeast. And the technique which we will use to obtain, because this will not give 100% yield, like we have a sugar solution, a container is there. In the absence of oxygen, we have a sugar solution, and in the presence of yeast, so it start to convert into alcohol. But the reaction is very slow process. Gradually, the sugar solution convert into alcohol, but that after certain time interval, the reaction stops. What is the reason why the reaction stops? Because in alcoholic condition, yeast cannot survive. So as the yeast cannot survive, the reaction stop, or very slow reaction is there. So how we can separate this alcohol from water, because or a sugar solution? So whenever we want to separate 2 or more miscible liquid, the technique which we use, we call that as a fractional distillation. So here we will use fractional distillation to obtain alcohol from water, or aqueous solution you can also say.